I want to take the inverse Laplace transform of this thing here. And I'm going to have to break this up due to this denominator. So I'm going to rewrite my fraction as s squared plus 9s plus 2 over s minus 1 squared s plus 3. So I'm going to rewrite this in a partial fraction decomposition. So as a reminder, when we do this, we're going to have several terms over here on the right-hand side. We notice our denominator here is completely factored. Everything is linear terms, but I do have one of them repeated. When I have a repeated linear term, I write that term down. The next term on the right-hand side will be that term squared, so s minus 1 squared. If this was cubed over here, I would then have an s minus 1 cubed, so I progressively get higher and higher powers of that term until I get to the actual power I had in the problem. And then for this particular problem, I'll have an s plus 3. And my numerators, a, b, c. We're then going to multiply everything by s minus 1 squared s plus 3. When we do that, this first side, the left-hand side, I'm left with s squared plus 9s plus 2. Here, one of the s minus 1's cancel. I'm left with a times s minus 1s plus 3. For the b term, both of the s minus 1's cancel. I'm left with b times s plus 3. And for my c term, the s plus 3's cancel. I'm left with c times s minus 1 squared. And once again, I'm going to pick nice values for s. I'm going to start with s being equal to 1. This left-hand side then becomes 1 plus 9 plus 2. The right-hand side, this a term will go to 0. I then have b times 1 plus 3. And this c term will also go to 0. So I have 12 is equal to 4b, or b is equal to 3. Next, I'm going to let s be equal to negative 3. Negative 3 squared is 9. 9 times negative 3 is negative 27 plus 2. On the right-hand side, this a term is going to go to 0 and the b term is going to go to 0. I'm left with c times negative 3 minus 1 is negative 4 squared. So this is negative 16 is equal to negative 4 squared is 16c, so we have c is equal to negative 1. Unfortunately, there's not another nice number I can pick to make both the b and the c term go to 0, but not the a term. So instead, we're going to have to do something else. I'm going to start by rewriting this and expanding out the right-hand side. I would have as squared plus 2as minus 3a plus bs plus 3b plus cs squared minus 2cs plus c. And then I'm going to look at the coefficients of s squared. That would give me a 1 on the left-hand side. The right-hand side is a plus c. I already know that c is negative 1, so I have that a is equal to 2. So with this, I can rewrite my transform. It said a over s minus 1 plus b over s minus 1 squared plus c over s plus 3. So now I need to take this inverse transform, and I'm going to need to use two facts for this. The first is that the transform of e to the at is 1 over s minus a. So this first term here will be 2 times e to the t, since in this case a would be equal to 1. The second term doesn't quite match that, but the third term does. So I'm going to leave some space. This would be minus e to the minus 3t, since in this case a would be equal to negative 3. The other one I need to match the second one is that the transform of e to the at t to the n is n factorial over s minus a to the n plus 1. In this case, if n is equal to 1, I would have this. So we would have 3 times e to the t, since in this case a would be equal to 1, times t, since n would also be equal to 1. So I have my inverse Laplace transform.